Well, hi there. Uh, I am Robert Font, a certified professional geologist and a proud member of the AIPG. Well, are you ready for some excitement? Because this is it. Uh, we're going to talk about the geology of the Caribbean. So hold on to your hats and fasten your seatbelts because here we go. I have to tell you that the Caribbean area was my playground during my youth and early teenage years. You see, I grew up in Cuba, uh, enjoying various water sports, swimming, fishing, snorkeling, and of course, playing baseball. Uh, Many years later, as a grown man, at the time living in Midland, Texas, when I was working for what is now ConocoPhillips, uh, guess what? Uh, I became a certified open water scuba divers. And for the next 20 years or so, uh, I enjoyed yearly diving trips to various portions of the Caribbean. Among my favorite dive sites are Cozumel Island of the Yucatan Peninsula of Mexico. That definitely was my favorite site and the one that I went to most often. Uh, Also, the Cayman Islands, St. Thomas in the U.S. Virgin Islands, uh, Bimini in the Bahamas, Belize. Uh, I only did one dive in Belize, but it was beautiful. And Roatan in Honduras. Keep in mind that the second largest barrier reef in the world is off the coast of Honduras. The top one, of course, being the Great Barrier Reef of Australia. So I can claim to have explored the Caribbean from the bottom up. Uh, Through work and pleasure, I have visited many of the islands in this tropical paradise. I had many uh, memorable diving adventures. Here I am holding a sea cucumber. On a personal note, let me tell you that although I grew up in Cuba, my father's family is from Catalonia or Catalonia. That's the northeast portion of Spain. And my mother's family from the Bordeaux area of France. So ethnically, uh, I am a Catalan, French, Cuban with sprinkles of Portuguese, Italian, and British in my background. But but most important, I am a very proud uh, U.S. citizen and a Texan, cowboy at heart. So God bless the USA. I left Cuba in 1961, and after a relatively short time in Florida, I moved to Texas. I can tell you that our great country gave me the opportunities and the freedom to pursue my dreams. So I am forever thankful. Kind of funny, the pictures that you see here, the one on the left, as far as I know, is the last picture that was taken of me while I was in Cuba. The one on the right, I'm already in the US. And notice that I'm wearing a sweater. Uh, I had never experienced cold weather before. Okay, now let's get down to the nitty gritty. Uh, I can tell you that the Caribbean Sea area is geologically very complex, as you will see. Uh, the area that we call the Caribbean region includes waters south of the Greater Antilles, west of the Lesser Antilles, and north of Venezuela and Colombia. It is also bordered on the west by Central America. Well, the main islands of the Caribbean include those that belong to the Greater Antilles and the Lesser Antilles. Uh, the Greater Antilles shown here by the blue pointers, uh, include Cuba, Jamaica, the island of Hispaniola, that consists of two countries, Haiti on the west and the Dominican Republic on the east, and the island of Puerto Rico. The Virgin Islands in the Bahamas, shown on the slide here by the red pointers, lie east of the Greater Antilles and north of the Lesser Antilles. The Virgin Passage, shown on the slide by the first orange marker, separates Puerto Rico from the Virgin Islands. And the Anegada Passage, shown here by the second orange pointer, separates the Virgin Islands from the Lesser Antilles. The Lesser Antilles volcanic arc chain, shown here by the purple bracket, is the volcanic island arc that lies south of the Anegada Passage. The main oceanic basin that defines the Caribbean Sea lies south of the shallow banks that will stretch from Honduras and Nicaragua to Jamaica and Hispaniola. The Beata Ridge, shown on the slide by the orange pointer, divides the Caribbean into a western part and an eastern part. I should mention at this time that the average depth of the Caribbean Sea is around 7,200 feet. West of the Aves Ridge, and the Aves Ridge is shown here by the blue pointer. West of that lies the Venezuela Basin with a water depth that approaches 17,000 feet. East of the Aves Ridge is the Grenada Plain and the Grenada Basin. And east of the latter, one finds the Lesser Antilles and their supporting ridge. The Cayman Trench or Cayman Trough, known in Cuba as the Bartlett Trough, lies between Jamaica and the southeastern tip of the island of Cuba. These are deep waters. The trough has a maximum depth of more than 25,000 feet. Several good scientists have written papers on the setting of the Caribbean area. I am listing on this slide some of the references that I personally like. So please take time in looking at this. These are also presented at the end of the presentation under the heading of references. I have, I think, all in all, more than 50 references. But these are the ones on this slide that I will suggest to you as some of the most significant in terms of the Caribbean setting. Okay, now before we talk about the geology of each specific island, we should say a few words about the Caribbean tectonic plate. The plate tectonic and structural development of the Caribbean area has been discussed by various authors. Again, on this slide, I am outlining for you some of the references that I think are most significant. Again, many authors have talked about this, but the ones that I have on this slide are the ones that I think have been very significant to me in looking at this specific topic. Once again, they're listed at the end of this presentation under the references heading. So I repeat myself, but there's more than 50 references in that section. Well, the Caribbean tectonic plate is an oceanic plate underlying Central America and the Caribbean Sea, uh, lying on the north coast of South America, with an area of about 1.2 million square miles. The Caribbean plate borders the North American plate, the South American plate, and on the west, the Nazca plate and the Cocos plate. Obviously, plate boundaries are regions of seismic activity and volcanic eruptions, and this is no exception here. The northern boundary of the Caribbean tectonic plate uh, is highlighted here by the red pointers. Uh, this northern plate boundary with the North American plate is a transform boundary, or if you will, a strike slip fault, which runs from the border area of Belize, Guatemala, and Honduras in Central America uh, eastward through the Cayman Trench. Part of the Puerto Rico Trench, which is, by the way, the deepest part of the Atlantic Ocean with a water depth greater than 27,000 feet, lies along this border. Now, the eastern plate boundary is where the action is. uh, this is a subduction zone where oceanic crust dives beneath the Caribbean tectonic plate. That boundary is highlighted on this slide by the orange pointers. Uh, Subduction at this convergent boundary forms the islands of the Lesser Antilles volcanic arc, uh, located between the Virgin Islands on the north and the islands of the Venezuelan coast on the south. You know what? 17 key active volcanoes are part of this arc. The most notable uh, are Soufriere Hills on the island of Montserrat, Mount Pelée on Martinique, La Grande Soufriere on Guadeloupe, Soufriere Saint Vincent on St. Vincent, and the submarine volcano Kikemjeni, about 10 kilometers north of Grenada. The southern plate boundary is shown here by the light brown pointers. Uh, Listen, this is a mess. It is geologically very complex, where the Caribbean plate interacts with the South American tectonic plate, forming, by the way, Barbados, Trinidad, and Tobago, as well as the islands of the coast of Venezuela and Colombia. This boundary is a combination of transform faulting along with thrust faulting and some subduction. Finally, we come to the western boundary. Uh, I will say that the western portion of the Caribbean tectonic plate contains Central America. The Cocos plate in the Pacific Ocean plunges beneath the Caribbean plate along the western coast of Central America. This subduction zone forms the Central America volcanic arc and accounts for the volcanoes that we find in Guatemala, El Salvador, Nicaragua, and Costa Rica. So definitely an active zone. So what are some of the key geological events that have affected the Caribbean area? Well, the Atlantic Ocean opened at the end of the Triassic as the North American tectonic plate rotated away from South America and Africa. In turn, by the way, the Yucatan area moved into the Caribbean region, forming the Gulf of Mexico. Uh, Closer to the Atlantic Ocean, a long and tapering sedimentary wedge was deposited in shallow waters, in a shallow sea. uh, essentially forming the Florida, Bahamas, Cuba platform. These movements continued until Cretaceous time. At this point, Central America, as far down as Guatemala, looked pretty much like its current day configuration. In addition, uh, South America had started to move westward, opening up the South Atlantic Ocean. Both the North American tectonic plate and the South American tectonic plate were diverging and drifting westward, uh, creating an ever increasing gap between them. Uh, and then a section of the Pacific tectonic plate moved in to fill this gap. And in doing so, the Caribbean tectonic plate came into existence, forming the Caribbean region. Now, a convergent boundary and the subduction that goes along with it developed, resulting in volcanic activity and the creation of the Greater Antilles. Initially, the Caribbean tectonic plate moved eastward and northward, pushing towards Cuba and the Bahamas. By the end of Cretaceous and into Paleocene time, subduction activity stopped in the area of the Greater Antilles and really started in the area of the Lesser Antilles, and it's still ongoing. You know what? At present time, the Caribbean plate is moving eastward at a rate of about 22 millimeters per year relative to the South American tectonic plate. And relative to the North American tectonic plate, the Caribbean plate moves east-northeast at about 20 millimeters per year. Silly in 1992 points out that the Caribbean plate uh, presently actually moves very slowly to the southwest, uh, but it is overtaken by the motion of both the North American plate and the South American plate. So relative to these two plates, the Caribbean plate moves in an eastwardly direction. Uh, we believe that plate migration started in the late Cretaceous. Now, pertinent to its genesis, there are two theories that account for the development of the Caribbean tectonic plate. The first theory sees the Caribbean large igneous province originally forming in the Pacific Ocean. But a second theory describes the Caribbean plate as developing from an Atlantic hotspot that is no longer in existence. Now, Seeley in 1992 has a real good summary of the sequence of events in the Caribbean area. Starting in Cretaceous, the Caribbean plate broke away from the Pacific plate. The islands of the Greater Antilles formed as a volcanic chain as a result of the subduction zone that developed in this area. In the Paleocene, the Caribbean plate started to move eastward, resulting in orogenic activity in the Greater Antilles, as well as Trinidad and in Venezuela. In the Eocene, subduction and the volcanism that goes with it came to an end in the Greater Antilles and began full steam ahead in the Lesser Antilles. In the Oligocene epoch, the Bahamas, Belize, and much of the Greater Antilles became shallow water banks, fringed, of course, by coral reefs. Uh, in the Miocene, Jamaica and Trinidad rose above sea level. In the Pliocene, the margins of the Caribbean plate were underthrusted and uplifted. The western leeward islands of the Lesser Antilles were formed at this time via volcanism. Pleistocene to present day, the islands of the Bahamas were formed, while Barbados and the Limestone Bank Islands took their current shape. Okay, now let's talk about some of these islands, and we will begin then with the Greater Antilles. Uh, by the way, those are shown on the diagram by the blue pointers. Uh, with a surface area of about 80,000 square miles, the Greater Antilles account for about 90% of the landmass of the West Indies. Uh, in the slides that follow, I will give you a summary of the geology of these main islands. Before I do this, I want to mention to you some of the key references that you should look into if you want to continue to explore this particular topic. And here they are. Listed on this slide are some of the works that I found extremely helpful in our understanding of the geology of the Greater Antilles. Uh, these references go all the way from 2016 to 1945. So I look at a whole spectrum of works in this particular area. I can tell you that some of the older works are really, really good because they have very good descriptions of what you see here. So these are listed in the reference section at the end of the presentation, but I definitely recommend these references to you. Okay, let's talk now about the physiography and the geology of Cuba. Now, I got to tell you that when I was growing up on the island, I had no idea that I was ever going to become a geologist. I did not discover geology until I was a junior in college. In fact, I wanted to be a professional baseball player, but I was never good enough. Uh, Interestingly enough, my paternal grandmother was at least part owner of some of the copper mines in the central portion of the island. So who knows? Who knows? Maybe I would have drifted in that direction anyway, but I don't know. Now, Cuba has an area of over 42,000 square miles. It has a length of 777 miles and a width of 119 miles. So it is a big island. Palmer in 1945 has described the main physiographic provinces of Cuba. Those are highlighted here on the diagram that I have presented here for you. You should know that the three main mountain belts in Cuba include the Organos Mountains on the west, the Trinidad Mountains in the central portion of the island, and the Sierra Maestra Mountains in the east. The highest elevation occurs in the area of the Sierra Maestra, and it is called Pico Turquino, with an elevation above sea level of nearly 6,500 feet. There are some iconic physiographic landmarks in Cuba. In the western area, in the area of the Organos Mountains. These are the famous Cuban mogotes, or limestone mounds in a karstic topographic depression, again in the area of the Organos Mountains. As a youngster, I remember climbing one of these mogotes. The western and central regions of Cuba are a deformed organic belt that formed from the collision of an island arc in the Cretaceous with the Florida Bahamas platform. Uh, Due to this collision, an ophiolite belt on the island became abducted, creating a northward leaning fold and thrust belt. Uh, Believe it or not, central Cuba has a zone of Proterozoic metamorphic rocks. Proterozoic. Who would have guessed that? Well, Jurassic and Cretaceous outcrops are very plentiful throughout the island. Well, let's talk about the orogenic episodes that took place in Cuba. Uh, the first and oldest tectonic episode, or orogeny, if you will, is of Jurassic age and consists of folded metamorphic rock. A second and subsequent pre-Cretaceous orogenic episode was responsible for the folding of some of the carbonates that are found on the island. A third and very intense orogeny, uh, characterized by folding and low-angle thrust faulting, occurred in the Eocene. A fourth orogenic episode took place in the Oligocene. But we're not finished. A fifth orogeny occurred in the Miocene epoch. Although it was not as intense in its degree of deformation as some of the ones before, uh, it actually raised the island into a single landmass rather than the previous system of scattered islands. Uh, Following this, high-angle block faulting occurred. In eastern Cuba, this deformation is represented by a north tilted fault block, the one that we call the Sierra Maestra. Now, as a point of interest, I have to tell you that Cuba's Cretaceous to Tertiary marine fauna consists of foraminifera, radiolarians, corals, echinoids, and mollusks. But here's the catch. The fauna is not considered characteristic of North America, but that which is closer to that is found in Egypt and Iran. How about that? Now, there are plenty of igneous rocks in Cuba. Uh, the intrusive rocks that we find on the island are both felsic and mafic. Uh, Felsic plutons are found in the southern part of Cuba, along the Trinidad Mountains, and in the Sierra Maestra. So we're talking the central and eastern portions of the island. Mafic plutons are more predominant, if you will, along the northern part of the island. Now, the extrusive rocks include about 6,000 feet of lava flows, volcanic tuff, and volcanic breccia. Basalt is the main component of the Sierra Maestra Mountains, with thicknesses somewhere between 13,000 and 18,000 feet. Basalt is found in the eastern side of the island, and pumice is found in central Cuba. Now let's summarize the important lithologies that we find in Cuba, and we'll start with the so-called basement rocks. Uh, Eastern Cuba has a Cenozoic volcanic arc composite with ophiolites occurring north and east of the Sierra Maestra on the eastern province of the island. The oldest rocks in Cuba are metamorphic and, like I told you earlier, of Proterozoic age. Other basement rocks are Jurassic and Cretaceous units. An ultramafic complex of serpentinized peridotite intrudes the older metamorphic strata, and in turn these ultramafics are overlain unconformably by Cretaceous volcanic tuff. Now, the Jurassic strata include an older sequence of about 35,000 feet of folded shales and slate and phyllite and schist, and a younger series of unmetamorphosed dark color limestone, shale, and chert with thicknesses that range somewhere in the 1,000 to 5,000 feet range. You should know that only Upper Cretaceous rocks are found in Cuba. Uh, the highly folded Cretaceous rocks consist of a clastic facies and a carbonate facies. The clastic facies is composed of coarse grain, calcareous sandstone, and marl that are capped by sandstone shale and a conglomerate with lithologic components that are not indigenous to the island. The carbonate facies is comprised of limestone along the northern side of the central portion of the island. Now, the Eocene rocks consist of shale and quartz sandstone in the western portion of Cuba. Eocene carbonate and clastic rocks are also found throughout Cuba. Uh, you should know that the sea was getting deeper throughout the Eocene in this area. Uh, Conglomerate and sandstone are overlain by other coarse grain clastic sediments, also by fine grain shale and deep water chalk. In the Oligocene rocks are mainly shale, limestone, and coral reef units. In the Miocene, most of Cuba was actually underwater. It was submerged. Uh, Carbonate deposition became widespread, uh, unconformably overlying the older lithostratigraphic units. Miocene rocks are also found in a few of the island's estuaries. As far as Pleistocene rocks go, these rocks are represented by terraces that are found in several parts of the island. Okay, now we have left Cuba and come to the island of Hispaniola. We will talk about its physiography and geology. Please refer to this sketch map that I have presented for you here so that you can understand better what I'm talking about. Now, Hispaniola is the second largest island of the Greater Antilles, and it consists of two countries, the country of Haiti in the west and the Dominican Republic in the east. The island is 400 miles long and 160 miles wide. Several northwest trending or oriented mountain ranges across the island. The main physiographic feature in Hispaniola is the Central Cordillera or Cordillera Central, which reaches heights of over 9,500 feet. The highest elevation is that of Pico Duarte, that has an elevation of 10,164 feet above sea level. That's pretty serious, huh? North of Hispaniola lies a narrow submarine trough that is 12,000 feet in water depth. Uh, the trough deepens to the east into the Brownstone Trough. North of this trough sits the shallow platform of the Bahamas. Uh, South of the island, a narrow shelf area uh, drops into deep water. The southern peninsula of Hispaniola passes into the submarine Beata Ridge that we have already talked about. Hispaniola actually began forming during Cretaceous time through island arc related plutonic activity. Uh, the island is really interpreted as being formed from various small and separate island arcs. Plutonic intrusions, metamorphism, and volcanism began concurrently on the largely submerged landmass. The Cordillera Central has abducted peridotite overlying a metamorphosed schist and mylonitic shear zone. Uh, the the basal metamorphic lithologies in Hispaniola are of Jurassic to Cretaceous age. They are exposed along the Cordillera Central of the Dominican Republic and also along the northern range of Haiti. Interestingly enough, the early orogenic episodes described for Cuba are combined in Hispaniola's basal complex. Uh, the time of great thrusting in Cuba was an interval of deposition in Hispaniola. Uh, Compressional uh, structures such as thrust faults and folds constitute the main form of structural deformation on the island. The current physiographic landscape result from a thrusting phase of Miocene to Pliocene age. The key lithologies in Hispaniola can be broken down into the basement complex and then pre-Cenozoic and Cenozoic rocks. Under the so-called basement complex, I should say that the oldest rocks include igneous rocks, uh, such as granite, quartz, diorite, andesite, basalt, and volcanic tuff. Uh, Also, sedimentary rocks, mainly in the form of carbonates, and metamorphic rocks such as schist and serpentine. These rocks, this basement complex, uh, makes up the axis of the Cordillera Central. Greenstone and amphibolite occur on the northern part of the island. Pre-Cenozoic strata consist of argillite in the north and limestone in the south. Other volcanic rocks occur in the Massif du Nord, the northern range of Haiti, which are overlain unconformably by marine and non-marine sedimentary strata, as well as radiolayer and chert. Cretaceous rudistis or rudist reefs unconformably overlie sedimentary lithologies. The Cenozoic strata consist of thick sedimentary rock units of Eocene, Oligocene, and Miocene age. Pliocene strata are found to the south, and Pleistocene rocks in general are pretty scarce on the island. Okay, now we come to the island of Puerto Rico. In high school, I had a friend from that country, and he used to tell me that uh, Cuba and Puerto Rico were the two wings of the same bird. Uh, uh, Perhaps it is because the flags of Cuba and Puerto Rico are just about identical, except that the colors are transposed. Well, let's talk about the physiography and the geology of this island. Uh, Puerto Rico is about 105 miles long by 35 miles in width. The Brownson Trough, or the so-called Puerto Rico Trench, lies just north of the island, uh, dropping down to an incredible water depth of more than 27,000 feet. Actually, more than 27,500 feet. Now, Puerto Rico sits on a plateau-like ridge that also holds the Virgin Islands uh, that lie to the east of Puerto Rico itself. South of the island of Puerto Rico, the sea drops to a depth of more than 17,000 feet. The Anegada Passage that we have talked about before separates Puerto Rico from the Lesser Antilles. On the west side of Puerto Rico, we have the Mona Passage with water depth of somewhere between 1,200 and 3,700 feet. It separates Puerto Rico from Hispaniola. As far as the physiography of Puerto Rico is concerned, please do refer to that sketch map that I have presented for you here on this slide. As you can see, the central part of Puerto Rico is comprised by a rugged mountain chain, the so-called Cordillera Central, that runs in pretty much an east-west direction. A complex of basement rocks makes up this central ridge. Uh, the average elevation in this range is about 2,000 feet above sea level, and the highest peak is Cerro de Punta, with an elevation of 4,356 feet. The Sierra de Luquillo and the Rio Grande Scenic Area occupy the eastern edge of the island. In terms of a geological summary for the island of Puerto Rico, we can say that this island consists of an extinct volcanic island arc terrain which started to form in Mesozoic time. Uh, the island began as an active volcanic arc related to the subduction of the Pacific tectonic plate beneath the western coast of South America. Uh, During the Cretaceous period, the island arc was propelled northward and eastward as the North and South American tectonic plates pushed westward around the newly creating Caribbean tectonic plate. An older series of tilted, folded, and overturned strata is found in the northeast portion of Puerto Rico. In this area, folds strike mainly northwest-southeast, and they're interrupted by flexures that run pretty much north-south. A younger series of structures is found on the north side of the island. This area is elevated but not really strongly deformed. The south side of the island is gently folded and faulted. The Mesozoic to Eocene orogenic episodes that we described and recognized in Cuba are imprinted in the older system of bedrock that we find in Puerto Rico. But it should be noted that only one post-Cretaceous to Eocene orogenic period or episode is distinguishable or recognized on the island. Cenozoic history in general appears to have been one of little structural deformation. The key lithologies that we find in the island of Puerto Rico can be summarized into the Mesozoic strata and the Cenozoic strata. Starting with the Mesozoic, we can say that an older volcanic system of Cretaceous age contains deformed and faulted volcanic tuff, volcanic ash, and intrusive plutons or igneous rocks, as well as some sedimentary strata like limestone, shale, and conglomerate. This system is found in the central and southern portions of the island. As far as the Cenozoic goes, a younger system of Oligocene and Miocene shales, sandstone, and reef limestone rests unconformably on the older bedrock. The younger sedimentary strata are found as marginal deposits on the north and south sides of the island. Well, last but not least in the Greater Antilles is the beautiful island of Jamaica. Please refer to the sketch diagram that I have presented for you on this slide so that you can see what I am talking about here. The highest area of Jamaica is the Blue Mountains range on the eastern part of the island. The Blue Mountains have a central ridge of metamorphic rocks surrounded by limestone. This central ridge is oriented in a northwest to southeast direction, with extensions that project both to the north and to the south. The highest peak that you find in Jamaica is the Blue Mountain Peak at an elevation of 7,402 feet above sea level. Uh, the Blue Mountains rise quickly from the coastline, and in about 10 miles of horizontal distance, you go from the coastline to these very high peaks. That gives rise to very steep gradients and very impressive landscapes. The John Crow Mountains lie to the north of the Blue Mountains. This John Crow Range is a tilted limestone plateau with elevations of around 3,300 feet. The limestone plateau, which covers about two-thirds of the country, please refer to the sketch map for reference. This limestone plateau lies to the west of the Blue Mountains in the central region of the island. The high rolling plateau on the north forms the Dry Harbor Mountains. Other high areas in Jamaica include the Nassau, Santa Cruz, Carpenters, Mocho, and Don Figueroa Mountains. As you could have guessed, karst topography is pervasive within the limestone plateau area. From the northern shore, the land rises in the form of gentle hills and continues into the high country. High cliffs are found along the southern shore. Keep in mind that Jamaica lies 90 miles from Cuba, separated by the deep water of the Bartlett Trough. Remember that water depth in the trough is in excess of 15,000 feet and reach more than 21,000 feet south of Cuba. The long and narrow peninsula of Haiti is about 90 miles from Jamaica, where the water depth is around 4,000 feet. South of Jamaica, water depth dropped down to more than 13,000 feet, approaching 14,000 feet. Jamaica and Honduras are about 900 miles apart. As far as a geological summary for Jamaica, I would say that the basement rocks of this island consist of island arc and back arc basin sequences of Cretaceous age that formed above a convergent plate boundary and its related subduction zone. Uh, the overlying strata are mainly shallow water carbonates that have been subsequently uplifted. A late Cretaceous to Eocene orogenic episode affected the island. Cretaceous rocks are tightly folded and oriented in a northwesterly direction. In the Oligocene, about 80% of the island of Jamaica was submerged. During this time, extensive limestone lithic units were deposited. The east-west elongation of the island is related to late Miocene epirogeny and faulting. Uh, Land rose in the Miocene along with intrusions of diorite and granite, and cross-faulting occurred in the Pleistocene. The key lithologies of Jamaica can be broken down into the Mesozoic rocks and the Cenozoic rocks. Let's talk about Mesozoic first. Uh, Basement rocks are covered by about 3,000 feet of volcanic material. Some Cretaceous fossiliferous marl and limestone are also present. This is the basement complex, if you will. As far as the Cenozoic goes, uh, clastic sedimentary rocks of, uh, of Eocene age also overlie the Cretaceous strata. Eocene rocks as well as Oligocene rocks are essentially limestone with thicknesses of more than 1,500 feet. These carbonates contain thick shell foraminifera that are indicative of water depth of more than 1,000 feet. Well, we have now finished with the Greater Antilles, and before we start with the Lesser Antilles, I would like to say a few words about the Bahamas. Uh, a little bit about the physiography and the geology of the Bahamas. Technically, the Bahamas are in the Atlantic Ocean and not in the Caribbean Sea. However, these islands are in the Lucayan archipelago along with Turk and Caicos and are generally associated with the Caribbean region. They definitely form part of the West Indies. The islands of the Bahamas include about 700 islands and keys and about 2,400 rocky mounds. The islands are typically flat and low. They resemble the Florida coast and the Florida Keys. On a personal note, immediately after being certified as an open water scuba diver, uh, my first diving destination was the island of Bimini in the Bahamian chain. The Bahamas are separated from Florida by the Florida Channel and from Cuba by the Bahama Channel. On the east side, the Bahamas platform drops sharply into the depth of the Atlantic Ocean. Now we're talking about serious depth here of about 15,600 feet. The greater part of the Bahama platform is covered by very shallow water, 18 to 25 feet deep. But submarine channels and submarine canyons cut through this platform. In terms of a geological summary, we can say that the region that encompasses the Bahamas may have been emergent to begin with, and the submarine canyons that we see today actually cut by subaerial streams. The area definitely underwent subsidence as much as 10,000 feet during Mesozoic and Tertiary time. Reefs began to build up as the subsidence continued, during which time the reefs grew vertically and also somewhat laterally. Reef buildup has been prominent in the history of the Bahamas. The emergence of the platform and the current island configuration began in Pliocene time. Well, I should say that whether or not the present day submarine canyons that we find in this area are a result of subaerial erosion or cut by submarine turbidity currents is still a topic of debate. But as far as the Bahamas go, the bottom line is that carbonate sediments are dominant in this area. Uh, the lithologies that were encountered in a deep well in Andros Island were summarized by Erdely in his excellent work in 1951. And those are shown in the little table that I'm giving you here. Notice that Cretaceous rocks occur from about 8,700 feet to more than 14,500 feet, and those are basically dolomite with some limestone. Paleocene strata from about 4,600 feet to 8,700 feet is also dolomite with some chalky limestone. The Eocene strata from about 2,200 feet to 4,600 feet is a sequence of alternating limestone and dolomite beds with some coquina. And the Miocene to Holocene strata, in essence from the surface to about 2,200 feet, is coquina, limestone, and a little bit of dolomite. Okay, now we come to one of the favorite areas for me concerning the Caribbean, the Lesser Antilles. I like active volcanic islands, and this would be it. The Lesser Antilles is the island arc located south of the Virgin Islands. The arc lies between the Greater Antilles to the north and west, and the continent of South America to the south. The islands form the eastern boundary of the Caribbean Sea and the Caribbean tectonic plate. Together, the Lesser Antilles and the Greater Antilles compose what we call the Antilles, and the combination of the Antilles and the Bahamas form what we know as the West Indies. As already mentioned, the Lesser Antilles coincide with the eastern boundary of the Caribbean tectonic plate. Many of the islands were formed because of the subduction of oceanic crust of the South American plate being thrusted under the Caribbean tectonic plate. This process is ongoing and is responsible for the volcanic and earthquake activity that we have in this area. The islands along the South American coast are the result of the interaction of the South American tectonic plate and the Caribbean tectonic plate. This southern boundary, as previously discussed, is extremely complex with both strike-slip motion and a compressional component. Now, on this slide, please refer to that sketch map so that you can visualize what I'm about to say. The geologic history of the Lesser Antilles is very complicated, as you will see, as reflected in the structure and the rock composition of the various islands. North of the island of Dominica, again, look at the sketch map. The arc is divided into two island chains. The eastern chain is an older extinct island arc and is covered by thick carbonate platforms. The western chain has been the site of active volcanisms since around late Miocene time. South of Dominica, the older and recent arcs are superimposed, forming one chain of volcanic islands. Many authors have covered the geology of the Lesser Antilles. Again, there are many references, but the ones that I'm listing here on this slide are the ones that I think are specifically important. They range all the way from works as recent as 2017 to way back to 1951. Again, some of the older references are very, very good because these people did a lot of good work. But these are the ones I suggest if you want to pursue further knowledge of the geology of the Lesser Antilles. These are also presented at the end of this presentation under the references section. In the slides that follow, I will give you a summary of the physiography and the geology of some of the islands in the Lesser Antilles. Specifically, I will refer to St. Martin, St. Lucia, Barbados, Martinique, St. Kitts and Nevis, Antigua and Barbuda, the Dutch Leeward Islands of Aruba, Curacao, and Bonaire, and Trinidad and Tobago. I have had the good fortune of having visited many of these. Well, first comes the island of Saint Martin. Uh, Saint Martin is a really interesting island because it is really two countries in one. You have the French side and you have the Dutch side. The main cities are Philipsburg on the Dutch side, as you can see on the map that I'm showing you here, and Marigot on the French side. The highest topographic feature on the island is Pic Paradis, 1,391 feet above sea level, in the center of a chain of mountains or hills on the French side. But both sides are hilly with mountain peaks. There are no rivers on the island. Uh, Sea stacks and sandy beaches occur throughout the coastline. Also, tilted and folded strata are visible on the island. Uh, Two distinct mountain chains are found in St. Martin in the central region and on the eastern coast, from Point Blanche on the south to the Baie de Embouchure uh, in the east central portion of the island. Here on you can see some of the typical views of this beautiful island of Saint Martin. On the left, you have the uh, typical topography. Uh, then you have some of the sea stacks that occur along the coastlines, intermixed with some beautiful sandy beaches, as you can also see here, and tilted strata that is commonly seen on the island. As far as the geologic summary for St. Martin, we can say that three volcanic phases are recognized on the island. The first two having occurred below sea level. Uh, Distinct lithologies in St. Martin consist of Eocene andesite, uh, volcanic tuff, volcanic breccia, which have been intruded by quartz diorite, basalt, and younger andesite. Volcanic activity led to metamorphism and the tilting and folding of the volcanic tuff and other rocks. Marl and limestone were subsequently and also unconformably deposited over the eroded volcanic rocks as volcanic activity shifted away from the area. The presence of large boulders, ridges, and solitary boulders on high cliffs may be indicative of storm and tsunami type deposits. Sandy beaches alternate with rocky coastlines, mainly composed of basalt, limestone, and marl. Caves are found in the limestone regions. The oldest rocks in St. Martin are Eocene to Oligocene volcanics overlain by Miocene sedimentary strata. Key lithologies in St. Martin range from Eocene to Quaternary. Uh, Eocene basement rocks consist of silicified volcanic tuff. These tuffs are found along the center of the island, along the eastern coast, and also scattered on the north and west. In the Oligocene, uh, the existing strata were intruded by a diorite batholith. Quartz diorites are found on the north and east central regions. Oligocene porphyrites and dolerites are present on the western side of St. Martin and around the diorite intrusions. In the Miocene, a moraine transgression occurred, resulting in the deposition of limestone and marl. Uh, these lithologies are found from the westernmost point of the island trending southeast to the end of Simpson Bay along the southern coast. You can refer to the sketch map that I have here for you to see that. Quaternary rocks include coral limestones and alluvial sands. These are found mainly on the westernmost area around Simpson Bay and also near Phillipsburg. Now we come to one of my favorite islands in this chain, St. Lucia. Please refer to the sketch diagram that I have here for you. The volcanic island of St. Lucia is more mountainous than most of the Caribbean islands. The highest point in St. Lucia is Mount Jimmy at an elevation of 3,120 feet above sea level. Two other mountains, the Gros Piton and the Petit Piton, are very famous in this area. The Gros Piton stands at an elevation of 2,526 feet above sea level, and the Petit Piton at 2,437 feet above sea level. They really form the most famous island landmarks. They are located on the western side of the island. I should say that the pitons are remnants of lava domes composed of dacite. They were formed somewhere in the neighborhood of 300,000 to 200,000 years ago. St. Lucia has a north-south running backbone ridge, the Bardil, with mountains increasing in size along the spine towards the south. Sulphur Springs is also a landmark of the island. As far as a geologic summary goes for St. Lucia, I would say that rocks in St. Lucia are mainly of volcanic origin and of Miocene to Pliocene age. Three periods of island building have been described during this time frame. The youngest volcanic event around Mount Jimmy connected portions of St. Lucia into a single landmass. The Soufriere volcanic complex occupies the southwestern portion of the island, just south of the city of Soufriere. The area contains the dacite lava domes, andesite cones, ash flows, pumice, and deposits of basaltic rocks. Mount Jimmy, the Gros Piton, and the Petit Piton are parts of this volcanic complex. You know, St. Lucia also claims an actual drive-in volcano, La Soufriere volcano or Sulphur Springs. Is located to the south of Mount Jimmy and the neighboring mountains. Hot water pools are found at temperatures of around 340 degrees Fahrenheit and downstream at about 110 degrees Fahrenheit. Sulfur gas in the form of hydrogen sulfide or H2S emanates from this area. The associated spring water is blackened by the chemical reactions between sulfur and iron. Other mineral deposits include iron oxide, copper, alkaline lead, and calcium oxide. The Sulphur Springs area lies within the Qualibuk caldera and the Qualibu Depression, which is a zone of structural collapse. Listen, spectacular landscapes are seen throughout the island. Here I am standing with the Petit Piton on the background. Again, please refer to the sketch diagram for reference. And here I am standing in the Sulphur Springs volcanic area. You can see the gases escaping in the background. Again, refer to the sketch diagram of the island for reference. I really find St. Lucia to be a strikingly beautiful island. You can see the topography here near the city of Soufriere, uh, but there's incredible landscapes all throughout the island. In terms of the distribution of volcanic rocks in St. Lucia, let me say this. Uh, Pumice is seen north of the city of Soufriere in the southwest zone, directly south of the Soufriere volcanic complex, and mixed with eroded basalt and andesite in the southernmost region. Andesite and pyroclastic aprons are found on the eastern side of St. Lucia and also along an east-west band in the north-central section. Dacite domes and dacite peaks are in the southwestern zone of the Soufriere volcanic complex. Again, keep in mind the sketch map that I did there for you, so you can use that as reference. Eroded basalts are found in the northern part of the island. Let's talk now about the island of Barbados. Uh, I try to collect a baseball style cap in every country that I go to. I'm way far behind because I've been in over 50 countries, but I'm wearing my Barbados cap right now. Uh, Please refer to the sketch diagram that you have here for reference. Uh, Barbados is in the Atlantic Ocean, uh, east of the other islands of the West Indies. So we can say that Barbados is the easternmost island in the Lesser Antilles. The terrain in Barbados is pretty flat in comparison to the neighboring islands to the west. The island rises gently to the central highland region, with the highest point being Mount Hillaby at 1,115 feet above sea level in the geological Scotland district. A large portion of the island is circled by coral reefs. Uh, Caves and gullies, as you would expect, are found in the limestone terrain on the Scotland district. Here you can see views of the Scotland district. Very pretty area. On this slide, you can see some of the sea stacks and erratic boulders uh, that you find along the eastern coast of Barbados. Uh, Again, please refer to the sketch map for reference. One thing that impressed me about Barbados is the steeply tilted strata that you see in portions of the island. Uh, Here you can see some examples of it. As a geological summary, we can say that Barbados lies on the boundary of the South American tectonic plate and the Caribbean tectonic plate. Subduction of the South American plate beneath the Caribbean plate scrapes sediment from the South American plate and deposits it above the subduction zone, forming an accretionary prism. Uh, the island is therefore rising at about 1 inch per 1,000 years. Uh, Pleistocene limestones cover a complex basement sequence of Eocene age consisting of a mixture of terrigenous and marine clastic sediments as well as marine deposits. Well, let's say a few words about the key lithologies in Barbados. We'll start with the Eocene basement rocks. The basement beneath the limestone cover is an alloctonous sequence of marine sediments. The oldest beds are clastic sedimentary rocks, which were folded, thrusted, and then covered by mud flows. Eocene turbidites and radiolarites are covered by Miocene gneiss in thrust contact with younger pelagic strata and volcanic ash. These rocks are intruded by diapirs with an organic mud matrix. Oceanic strata were deposited over the basement complex. Older limestones occur in the central portions of the island. Biomicrites, chalk, radiolarian earth, and volcanic tuff were folded, uplifted, eroded, submerged, and covered with Oligocene to Miocene marl. Barbados is covered with Pleistocene limestone formations. Miocene to Pliocene folding and post-Pleistocene uplift and fracturing are seen in the island. The coalescence of discontinuous coral reefs and ongoing tectonic movements during eustatic low stands form a series of terraces consisting of back reef, reef crest, and fore reef deposits. Okay, now we come to the island of Martinique. Uh, no, I do not have a Martinique cap. Please refer to the sketch diagram that I have presented here for you. Uh, the total area of Martinique is 420 square miles. Martinique is the third largest island in the Lesser Antilles after Trinidad and Guadeloupe. It is 43 miles long and 19 miles wide. The highest point in Martinique is the volcano Mount Pelée at an elevation of 4,583 feet above sea level. The northern, central, and western areas of the island are mountainous. The south side has gentler topography, but listen, it still houses some very impressive geographic landscapes. As a point of interest, I will tell you that Martinique is the home of a very dangerous poisonous snake, the fer de lance. In fact, the unofficial flag of Martinique is the drapeau à quatre serpents, which is a blue and white flag with 4 snakes. You can see that on the sketch that I have here for you. Martinique is primarily a volcanic island. Volcanic action in the south and central portions of Martinique uh, date back to the Miocene epoch. In contrast, the volcanic action in the northern section of Martinique is Pleistocene to recent. Mount Pelée is the infamous volcano that lies within Martinique. It formed about 400,000 years before present. This volcano has erupted in 1792, in 1851, and twice in 1902. The May eruption of 1902 on Ascension Day destroyed the city of Saint Pierre and killed about 29,000 people in a matter of 2 minutes. And here's a pretty good picture of Mount Pelée that I was able to take when I was in Martinique. You can see the volcano and you can see how close to that volcano is the city of Saint Pierre. This is what impressed me the most. The fact that this city is just next to the volcano. So these people in 1902 had no chance. Volcanic rocks in Martinique include orthopyroxene andesite, hornblende andesite, quartz hornblende andesite, quartz biotite andesite, olivine basalt, and a tridymite-rich dacite. Their location and distribution are summarized in this table that I have presented here for you. The late Oligocene to early Miocene is comprised or consists of the older rocks that we find in Martinique. Uh, these are andesitic lavas from the late Oligocene to early Miocene, mixed with those of basaltic composition. Now, Martinique has a basal complex of Oligocene rocks in the southern portion of the island. Miocene volcanics are found in the southeastern region of Martinique and middle to eastern portions of the island. And Pleistocene volcanic strata are located in the northern half of Martinique. Now we come to another one of my favorite islands here in the Lesser Antilles, the area of St. Kitts and Nevis. Please refer to the sketch map there for reference. And yes, I do have a baseball style cap for St. Kitts and Nevis. You know, St. Kitts has the typical topography and rock deformation that is expected in the volcanic island arc. St. Kitts has three distinct groups of volcanic peaks. These include the northwestern or Mount Misery Range, the central Verchals Range, and the southeastern Olivis Range. The highest peak in St. Kitts is Mount Liamuiga at 3,793 feet above sea level. Here's are some pretty pictures of the area of St. Kitts. You can see the headlands and bays and the beautiful beaches that you find in this area. Striking island. And for those of you that like examples of rock deformation, there's plenty of it here in the area of St. Kitts and Nevis. You can see here on the slide a good example of it. One of the famous landmarks in St. Kitts is Timothy Hill. The overlook at Timothy Hill in the northern end of the Southeast Peninsula is a landmark for the island because it separates the Caribbean Sea from the Atlantic Ocean. Again, you can refer to the sketch map that I have prepared for you so you can see that. The island of Nevis has 7 volcanic centers and is dominated by Nevis Peak at an altitude of 3,231 feet above sea level. In terms of a geological summary, we can say that volcanic rocks are dominant on the islands of St. Kitts and Nevis, including andesite, dacite, pyroclastic debris, and volcanic ash. Coarse grained clastics and agglomerates can also be found. The 3 volcanic centers in St. Kitts are Pliocene to Pleistocene in age and get progressively younger from southeast to northwest. Mount Liamuiga is a stratovolcano consisting of alternating andesitic and basaltic lava flows and pyroclastic debris, which is located in the north central part of the island. The volcanic centers in Nevis developed from Pliocene to Holocene time. The island of St. Kitts can be divided into 3 distinct sections. Please refer to the sketch map. We have the salt pond area in the southeast containing lava domes, lahars, and pyroclastic debris. You have the Southeast Peninsula, which is the result of 7 islands coalescing from previously existing tombolos. The highest peak on the peninsula is St. Anthony's Peak at an altitude of 1,046 feet above sea level. The Timothy Hill overlook that we already talked about is located at the northern end of the peninsula. Uh, as far as the main portion of the island, a central chain of volcanic mountains is present. The core of the range is composed of Eocene, Miocene, and Pliocene volcanic lithologies. Uh, Pyroclastic fans and lahars are found at lower elevations. Another pretty set of islands in this area includes the islands of Antigua and Barbuda. Uh, Notice I'm wearing my baseball style cap from Antigua and Barbuda. Uh, Antigua and Barbuda, and oh yes, please refer to the sketch map for reference here. Antigua and Barbuda are located to the east of St. Kitts and Nevis and south of St. Martin. The two islands are 20 miles apart. Antigua and Barbuda have a surface area of 108 and 62 square miles respectively. The highest elevation in Antigua is Boggy Peak, also known as Mount Obama, with an elevation of 1,319 feet above sea level. Topographic highs occur in Antigua in the southwestern region. A famous landmark in Antigua is Shirley Heights, separating uh, English and Falmouth harbors. Barbuda is mainly flat, formed by coral reefs. And here's a nice view from the Shirley Heights area in Antigua. Uh, Again, please refer to the sketch map. As a geological summary, we can say that both Antigua and Barbuda have carbonate strata over volcanic rocks of Eocene age. In the Oligocene epoch, Antigua transitioned from volcanism to limestone deposition. And as you could expect, karst topography is present in the limestone areas. Antigua can be described by three main sections. The northeastern portion of the island is dominated by Oligocene age fossiliferous limestone as well as marl. Coral biostromes and patch reef material are overlain by fine-grained deeper water limestone. Now the central plains are covered with shale, conglomerates, agglomerates, and volcanic tuff with chert beds and limestone lenses. The southwestern highland area can be described as this, or as follows. Calc alkaline, andesite, dacite, and quartz basalt, as well as limestone lenses and tuff, are present in this area. Some of these lithologies are strongly metamorphosed. Agglomerates of pyroclastic tuff, lava flows, and intrusive rocks are also found here. There are other islands in the Lesser Antilles chain that I have not had the opportunity to visit. I am not familiar enough with their physiography and geology uh, to comment on them in this work. I would refer you to Allen 2017 as a good reference for these areas. These islands include Montserrat, Guadeloupe, Dominica, St. Vincent, and Grenada. Montserrat, Guadeloupe, and Dominica lie between St. Kitts and Nevis on the north and Martinique to the south. St. Vincent and Grenada are located south of St. Lucia. Those are shown on the little sketch diagram that I'm showing you here. Okay, next we're going to talk about the Dutch Leeward Islands of Aruba, Curacao, and Bonaire. Now, These three islands have a distinct and an unmistakable Dutch flavor. Uh, if you notice, I'm wearing my American Dutch cap here. Um, and you can see some views of these islands on this slide that you have here. The islands originated via volcanic activity. The island of Aruba has an area of 69 square miles. The highest point on the island is Mount Yamanota at 690 feet above sea level. Curacao encompasses 171 square miles. Mount Cristobal at 1,236 feet above sea level is the highest point. Bonaire covers 111 square miles, and Brandaris Hill at 787 feet above sea level is the highest point on the island. The islands of Aruba, Curacao, and Bonaire are aligned along the crest of a 125-mile-long segment of the east-west trending Leeward Antilles Ridge within the Caribbean and South American plate boundary area. The region is currently undergoing east-west or right lateral strike slip motion. Basement rocks include deformed intrusive and extrusive igneous lithologies such as diorite and gabbro, as well as radiolarian chert, limestone and greywacke. Those are your sedimentary rocks. The basement rocks were deformed in Cretaceous time. Quartz augite diorite and quartz diorite intrude the basement rocks in Curacao and Aruba respectively. The deformed igneous rock units in these Dutch Leeward Islands are unconformably overlain by Cretaceous to Eocene sediments. Compressional stresses resulted in additional folding of strata in the Eocene epoch. So let's talk about the core rocks, of these islands. Let's start with Aruba. Core rocks in Aruba are stratified basalts and volcanoclastics intruded by a tonalite batholith. The oldest rocks are Cretaceous and are found from north to south along the eastern and central portions of the island. Miocene, Pliocene, and Pleistocene reefs, eolanites, and terraces cover the western, southernmost, and southeastern areas of the island of Aruba. In Curacao, the core rocks include lava flows, silica-rich lithologies, and clastic sediments, such as conglomerate, sandstone, and shale. The oldest rocks are Cretaceous, which cover most of the southern part of the island and the northern end as well. A few Eocene lithologic units occur east of the Cretaceous zone. Miocene, Pliocene, and Pleistocene terraces occur close to the coast, especially on the east side. As far as Bonaire goes, the core rocks are basaltic lava flows and pyroclastic deposits interbedded with pelagic, radiolarian, chert, and other limestones. The sequence is overlain by turbidite conglomerates, fluvial sediments, and limestone. The Cretaceous strata are found in the central zone and in the northwest tip of the island. Everywhere else, Miocene, Pliocene, and Pleistocene terraces are found. Well, next we're going to talk about Trinidad, Tobago, and Margarita Island in Venezuela. Uh, as far as Trinidad goes, I will tell you that when I was head of my company, I ran my own company for 23 years. One of my lieutenants in the company uh, was a person from Trinidad uh, of Hindu descent, a great gentleman and a very good geologist. I have not had the pleasure and the opportunity to visit these islands in person, but during the years that I taught professional courses for PDVSA, uh, Petroleums of Venezuela, in Caracas, I became somewhat familiar with this region. The island of Trinidad has an area of 1,850 square miles. It lies about 7 miles northeast of Venezuela and is part of the South American continent. The highest point on the island is El Cerro de Laripo at an altitude of 3,083 feet above sea level. Trinidad is crossed by three distinct mountain ranges that are a continuation of the Venezuelan uh, coastal cordillera. The northern ranges uh, is basically an outlier of the Andes Mountains of Venezuela and forms rugged hills that parallel the coast. El Cerro de Laripo is located within this range. The central range extends diagonally across the island uh, and is a low-lying range with swampy areas with a maximum elevation of about a little over 1,000 feet. The southern range contains a broken line of hills with a maximum elevation, again, also about 1,000 feet. Please refer to the sketch maps that I have built here for you. Now, Tobago has an area of 115 square miles and is located about 20 miles northeast of Trinidad. Tobago is mountainous and is dominated by the 18-mile long main ridge uh, with elevations of about 1,800 feet. We can summarize the geology of Trinidad as follows. Uh, the Eocene classic sedimentation and diastrophism and Miocene to Pliocene folding of Barbados is also represented in Trinidad. Jurassic and Cretaceous rocks crop out on the island as part of the folded northern range. The oldest sequences include phyllite, quartz veins, and limestone. A younger system of less metamorphosed Cretaceous strata include limestone and shale. Folding in the North Range occurred first in the Cretaceous, followed by some minor volcanic activity. Uh, Sedimentary deposition followed. Folding resulted from a strong Miocene diastrophic episode. The schist that is found in the North Range of Trinidad and in northern Tobago exhibit a similar degree of metamorphism. Tobago lacks the limestone and graphite schist of Trinidad, and in turn, Trinidad lacks the metavolcanic schist of Tobago. Igneous activity in Trinidad was minimal compared to that you find in Tobago. As far as Tobago goes, Cretaceous metamorphosed volcanic rocks are found along the northern part of the island. Schists and phyllite are seen in isoclinal folds. To the south, there is an igneous belt of ultramafic rocks and also diorite-rich plutons, as well as andesite and basaltic flows and lithologies. These rocks were later faulted in the Eocene. Undeformed fossiliferous clay and sand of Miocene to Pliocene age lie unconformably over the deformed igneous belt. Margarita Island belongs to Venezuela and it's not too far from Caracas, a city that I visited several times when I was, again, teaching courses for PDVSA and in my various trips to Venezuela. Uh, Schists are intruded by shear quartz diorite and serpentinized peridotite. These are found on the northern part of Margarita Island. South of the schist area, slightly metamorphosed sediments are found. Further to the south and along the southern coast of the island, Cretaceous sediments are folded into a syncline. The main diastrophic episode occurred in Cretaceous time. Uh, Miocene ultramafic rocks are seen also on the island. Moderate deformation occurred in the Eocene to Miocene time frame. We're almost at the end of our discussion of the Caribbean, but uh, I would say that we could not finish a treatise on this area. Uh, it would not be complete without mentioning the Virgin Islands. The Virgin Islands lie along the northern boundary of the Caribbean tectonic plate. These islands are located at the eastern end of the Greater Antilles and at the northern end of the Lesser Antilles, if you will, within the transition zone between strike-slip motion and subduction activity. Islands in the northern section of the Virgin Islands have higher elevations than those that you find toward the south. Mount Sage on Tortola and Crown Mountain on St. Thomas stand at elevations of 1,709 feet and 1,551 feet, respectively. In contrast, Mount Eagle in St. Croix reaches an elevation of 1,161 feet. The interior landforms of the northern igneous section are dominated by steep slopes and deep guts. Well, the Virgin Islands are basically beautiful islands. You see here some views of one of my favorite islands in the area, St. John, which is part of the U.S. Virgin Islands. I hope that you refer to the little sketch map that I did here for you so that you can see the basic division between the U.S. and the British Virgin Islands. In terms of a geological summary for the Virgin Islands, and please refer to the little sketch map that I built for you so that you can see what I'm talking about. We can say that the area of the Virgin Islands may be divided into two, east-northeast, west-southwest, veering tectonic zones separated by the Anegada Trough. The northern section is dominated by igneous lithologies and is a continuation of Puerto Rico. It encompasses the U.S. Virgin Islands of St. Thomas and St. John, as well as the British Virgin Islands of Tortola, Virgen Gorda, and Anegada. This zone exhibits north-trending, steeply dipping beds related to post-Eocene tectonics and is not associated with the intrusion of the Virgen Gorda batholith. In contrast, the southern section is primarily formed by sedimentary units. It contains a submarine ridge south of and parallel to the Anegada Trough, in addition to the island of St. Croix. St. Croix is characterized by a central graben filled with tertiary strata, bound, of course, by horsts of, of Cretaceous rocks. Rocks in the Virgin Islands are older in the north and younger in the south. A description of the strata found in the north and in the south is summarized in this little table that I have built for you. As far as the northern area goes, we can say that igneous rocks in the north are Cretaceous in age, but the strata are Miocene in age, for example, in St. Croix. Uh, Igneous rocks in the north are intrusive and extrusive uh, keratophyres of intermediate composition. These are mainly lava flows, volcanic breccia, and tabular igneous dikes. Uh, Lesser amounts of basalt and gabbro, as well as radiolarian chert, can also be seen in this area. The igneous lithic units are overlain by clastic and carbonate sediments. When you go to the south side, uh, this southern sedimentary section contains fossiliferous shale, sandstone turbidites, conglomerates, and tufaceous deposits. The youngest sedimentary units are mainly shale with interbedded conglomerates overlain by foraminifera rich and gastropod rich limestones. Two tonalite batholiths are worthy of mentioning in this area. These are the Virgen Gorda batholith and the narrow batholith. The latter positioned between St. John and Tortola. Diabase and diorite dikes were fed from these batholiths, resulting in contact metamorphism of some of the Eocene rocks. As a personal note, one of my most memorable diving experiences was in the waters of St. Thomas in the U.S. Virgin Islands. Along with a group of scuba divers, we descended to a shipwreck. Now, inside of the ship was a large nurse shark. Uh, as some of my buddies were taking pictures of the animal, it became spooked, and as it swam away with a flick of its tail, it took off my mask from my face. Listen, I was lucky that it didn't knock me unconscious or drive my regulator all the way down my throat. As you can imagine, this little incident made a long lasting impression in my diving adventures. Well, we have pretty much now reached the end of our little discussion on the Caribbean. I hope you have learned something and that you have found these somewhat interesting. I have over 50 references that I have listed here. These are all excellent works. Some of them concentrate on the Greater Antilles, some concentrate on the Lesser Antilles, or the Virgin Islands, or the Bahamas, or the Dutch Leeward Islands. These are by no means the only references available, but these are the ones that I specifically found helpful to me, and I can guarantee you they're quite informative. So I would say that if you're interested in this topic and learning more about the geology of the Caribbean, uh, these are references that I highly recommend to you. And with this, I close. And again, thank you for listening and see you later. Take care. Bye bye.